Okay, students. So we will go through Unit 1 is machine learning. Unit 1 is theoretical concepts. So already we discussed a few of the topics of machine learning, but let us go through as per the syllabus. Machine learning is a subset of artificial intelligence that involves the development of algorithms and statistical models that enable computers to perform specific tasks without explicit instructions. And the history in 1959, Arthur Samuel coins the term machine learning. In 1980s and 90s, some sophisticated algorithms were developed, and 2010s till to present, there is a huge impact of machine learning. And with the development of deep learning and big data, machine learning is very much prevalent and being used for so many tasks. There are three types of machine learning. You have, in fact, four types: supervised learning, unsupervised learning, semi supervised, and reinforcement. Supervised learning, the model is trained on labeled data. Example are regression and classification. Applications are email spam detection, image recognition. Unsupervised learning is model finds hidden patterns in unlabeled data. Example clustering association. Applications are market basket analysis, customer segmentation. Semi-supervised learning combines a small amount of labeled data and a large amount of unlabeled data. And the applications are web content classification. Reinforcement learning model learns by interacting with the environment to achieve the goal. Examples are Q-learning, deep Q-learn networks. Applications are game playing, robotics. What are the different types of algorithms? Is it clear so far? Four types of machine learning: supervised, unsupervised, semi supervised, reinforcement. Supervised works on label data. Examples are regression classification. Unsupervised works on unlabeled data. Example clustering association. Semi supervised, little bit of label data and large amount of unlabeled data. Example web content classification. Reinforcement learning, it is about interacting with the environment to achieve the goal. Example, Q-learning, deep Q networks. Okay, now key algorithms. What are the algorithms under supervised learning algorithms? They are linear regression, logistic regression, decision trees, support vector machine, neural network. These are important ones. There are so many other algorithms. Unsupervised important ones are k-means, hierarchical, PCA, principal component analysis, T-distributed stochastic neighbor embedding, TSNE. For reinforcement learning, algorithms are Q-learning, deep Q networks, policy gradient methods. Machine learning workflow includes data collection. First, you have to collect the data from various sources, then you have to prepare the data, you have to clean the data, you have to normalize the data, and you have to transform the data. Model selection, you have to choose the appropriate algorithm depending on the type of data. And what is training? Well, the training is feeding the model with the training data. Evaluation is assessing the model's performance using test data. Deployment is implementing the model in a real world scenario. Monitoring and maintenance is continuously monitoring and updating the model as needed. What are the applications of machine learning? Well, there are so many applications. In healthcare, you can use for predictive diagnostics, personalized treatment plans, finance, fraud detection, algorithmic trading, in retail, in manufacturing, in transportation, entertainment. So every field now uses machine learning in some way or the other. What are the advantages? First one is automation. It reduces human intervention in repetitive tasks. Scalability, it can handle large volumes of data. It can improve decision making. It can personalize, uh, the enhances the user experience by tailoring the content and services. Challenges in machine learning. In machine learning, you have to focus more on the data quality because models are as good as the data. Algorithm selection. You have to Be very careful about choosing the right algorithm. Then the machine learning suffer from the problem of overfitting and underfitting, which is nothing but balancing the model complexity uh, to avoid these. Then you have some ethical concerns. There may be some bias in the data. There may be some privacy concerns. There are computational resources requirement of for machine learning is very high. Those are the challenges. Future of machine learning is about integrating it with IoT and having some advancements in deep learning. Explainable AI is another area which is the future of machine learning. Edge computing is also very, going to be useful in future in for upcoming research. The conclusion is that here machine learning is a transformative technology that leverages data to enable systems to learn and make decisions. Okay, now we'll look at the types of machine learning in detail. Supervised machine learning, as we know that in this, a model is trained on the labeled data set and each training example includes input-output pair. Key characteristics, that is, it depends on the labeled data and uh, it is about predictions. Common algorithms are linear regression, logistic regression, decision trees, support vector machine, neural network. These are common algorithms. Applications are email spam detection, then image recognition, credit score. Unsupervised learning description, it deals with unlabeled data. Key characteristics is the data does not come with the labels and model try to infer patterns from the input data alone. So pattern detection, the goal is to identify the pattern, grouping, or structure in the data. Common algorithms are k-means clustering, hierarchical clustering, principal component analysis, t-distributed stochastic neighbor embedding. Applications of unsupervised learning is customer segmentation, that is grouping customers based on purchasing behavior. Anomaly detection is identifying the unusual data points in datasets. Market basket analysis is finding association between different products in transaction data. Semi-supervised learning, it uses small amount of labeled data and large amount of unlabeled data during training. So it is combination of both labeled and unlabeled data. It is cost effective because it reduces the cost that is incurred to label the data. Common algorithms are the self-training and co-training and transductive SVM. Applications are web content classification, speech recognition, text classification. In reinforcement learning, it is an area of machine learning where an agent learns to make decisions by performing actions in an environment and it wants to achieve the maximum reward. The key characteristics are trial and error and it explores and exploits. Common algorithms are Q-learning, deep networks, policy gradient methods. Applications are game playing, robotics, resource management. These are the applications of reinforcement learning. Now again we will begin supervised learning and study it in more detail. So far we have learned about definition of machine learning, types of machine learning. Now we will look at the first type of machine learning, which is supervised machine learning. Again, let us look at the definition that supervised learning is a type of machine learning where the model is trained on a labeled dataset. The algorithm learns to map input to output based on the provided labels. As labels are provided by making use of the labels, it maps input to output and it enables making predictions or classifications on new and unseen data. The core concepts here is the goal is to learn a function f that maps input x to output y, where y is known during training. Y is actually the label or the output which is known during training but unknown during testing. Key characteristics include the labeled data, training process, prediction. These are the key characteristics of supervised learning. Common algorithms. First one, regression algorithm. Linear regression. It models the relationship between a dependent variable and one or more independent variables using linear approach. The equation is y equal to beta naught plus beta 1 x plus e epsilon. So beta naught and beta 1 are known as coefficients or weights, and x is the input, y is the output. X is independent variable, y is dependent variable, y is also called as the target variable or a label. Applications include predicting house price, forecasting sales. Then polynomial regression. Linear regression is using only a single variable, whereas polynomial regression uses multiple variables x1, x2, up to xn. It models nonlinear relationships. Classification algorithms are, this is regression. Classification used for binary classification or multi-class classification based on the probability of the instance that belongs to that class. The equation of this is 1 upon 1 plus e power beta naught plus beta 1 into x. So in this exponentiation we use e to the power of minus this beta naught plus beta 1 into x. Applications are spam detection, disease diagnosis. Decision tree is also a algorithm for classification as well as regression, both. Decision tree looks like a tree, and it has internal nodes that represent features and branches that represent decision rules, and the leaves represent the outcomes. The leaf means the last level. Of in a tree we have the last level which is representing the outcomes. Algorithm name is CART, CART, which means classification and regression trees. Application are credit scoring and medical diagnosis. Another classification algorithm is SVM, which stands for support vector machine. SVM, it finds the hyperplane that best separates the classes in the feature space. And there is a kernel function, linear, polynomial, radial basis function. Applications are image classification, text categorization. And k nearest neighbor, KNN, it classifies an instance based on the majority class among its k nearest neighbors. It looks for the nearest neighbors, and it based on nearest neighbors, it classifies the new instance. The distance metrics used is Euclidean distance, Manhattan distance, Minkowski distance. Applications are handwriting recognition, recommendation system. Another algorithm is a neural network. It is composed of interconnected layers of neurons. It is suitable for complex pattern recognition tasks. Example are feed-forward neural network, convolutional neural network, recurrent neural network. Applications for neural networks include image recognition, speech recognition, and so on. Workflow of supervised learning. So already we saw it again. We will revisit it in more detail. Here we will collect the data. We gather a labeled data set. Data pre-processing involves cleaning the data, normalizing the data, encoding the data. Cleaning means handling missing values. Normalizing is scale the features to a consistent range. And encoding means converting categorical variables into numerical variables. Data splitting is to the entire data set is divided into two parts useful for training and testing. Typically 70 to 80% is useful for training, and 10%, if you use 70% for training, 10% you use for validation, which is useful for tuning the model parameters. A test set is used to evaluate the model's performance. Please remember these terms. Training set means train the model. Validation means tune the model parameters. Test set means evaluate the model's performance. These three phrases you please remember. Model selection is depends on the type of the data, whether you are doing regression or classification. Then training is performed on the training data, and you can adjust the parameters to minimize the errors. Evaluation, for evaluation, you may use a mean absolute error. These are the metrics. A mean squared error, R squared. The metrics for classification include accuracy, precision. This, look at here, students, metrics for regression is different from metrics for classification. For regression, it is mean absolute error, mean squared error, R squared. For classification, it is accuracy, precision, recall, F1 square, ROC, AUC curve. Hyperparameter tuning is to optimize the model performance by adjusting the hyperparameters, which are which may use the techniques like grid search, random search, Bayesian search. Deployment is implementing the trained model into the production environment. Monitoring and maintenance is, once you deploy the model, you have to maintain it. Applications of supervised learning, as we saw earlier, same thing here, it is repeated, but with examples in healthcare, in finance, in retail, in marketing, manufacturing, transportation. The advantages is it is of high accuracy when model is trained on a large representative labeled data set. And some of the machine learning models support interpretability like decision tree and linear regression. They are easy to interpret, whereas other models are not easy to interpret. And it supports versatility. It can be applied to wide range of applications and industries. The disadvantage is that it depends on the data. It requires large amount of labeled data, and generating labeled data is expensive and time consuming. And it may suffer from the problem of overfitting. Overfitting means a model is performing well on trained data but poorly on new and unseen data. That is known as overfitting. Computationally intensive, yeah, training complex models like neural network and all require significant computational resources. Let us look at unsupervised learning. Again, unsupervised learning works on unlabeled data. It identifies the patterns, structures, and relationship within the data. So this phrase you please remember: patterns, structures, relationship within the data. The core concept is that model infer the natural structure present within the set of data points. The key characteristics are unlabeled data, pattern detection, and exploratory analysis. And then we have common algorithms, k-means clustering. K-means clustering partitions the data into k clusters, where each data point belongs to the cluster within the nearest mean. These are the steps. Again, we will look at it in detail in Unit 4. Here, it is just the introduction. Initialize k centroids, assign each data point to the nearest centroid, recompute centroids as the mean of the assigned points, repeat until convergence. Application include customer segmentation, document clustering. Hierarchical clustering is building hierarchy of clusters using either a bottom-up or top-down approach. DBSCAN is density-based spatial clustering of applications with noise. This is another unsupervised learning algorithm. This DBSCAN identify the core points with a minimum number of neighbors within a radius. It expand cluster from core points, label points that do not belong to any cluster as noise, and the application includes geographic data analysis and anomaly detection. Another application of unsupervised learning is dimensionality reduction. It has algorithms which are PCA and TSNE. PCA, it reduces the dimensionality of the data. And these are the steps. Compute the covariance matrix, calculate the eigenvalues and eigenvectors, project data on top principal components. TSNE, the steps are to compute pairwise similarities in high dimensional space, map data to low dimensional space, and applications are visualizing clusters in complex datasets. And independent component analysis is also another mechanism where you decompose data into statistically independent components. You center and widen the data and find the independent components through iterative algorithm. Association rule mining is another method where you try to find the association between the items. Algorithm name is a priori algorithm. It identifies frequent item sets. The steps are generate candidate item set, calculate support for item set, prune infrequent item set, generate association rule from frequent item set. Another algorithm is eclect algorithm. It is an alternative to a priori algorithm. It uses depth first search. The steps are generate candidate item sets, calculate support for item set, prune infrequent item set. Then the workflow for unsupervised learning. You saw the workflow of supervised learning where we have collected the data, we have cleaned the data and trained the data and evaluate the data. Here also first thing is data collection. Here we collect the data without labels. We pre-process the data, cleaning, normalizing and dimensionality reduction. Then you have to choose the algorithm, you have to train the model, you have to evaluate. There under supervised we saw two types, regression and classification. For regression we saw that mean squared error is one of the metrics, accuracy is one of the metrics for classification. Here for clustering the metric name is Silhouette score, and for dimensionality reduction it is through visualization and variance. For association rules the metrics are support, confidence and lift. Interpretation involves analyzing the patterns, clusters, or rules discovered by the model. Deployment is to implement the findings into practical applications. And finally, you have monitoring and maintenance. Once you deploy the model in the industry, you can monitor and maintain. Applications include customer segmentation, anomaly detection, market basket analysis, document clustering, image compression, genomic data analysis, social network analysis. Advantages and disadvantages include the major advantage is that there is no need to label the data. If you have any doubt, you put in the message, students. Then it has the exploratory power. It can discover the hidden patterns and it is versatile. It can work with a wide range of problems and data types. Disadvantage includes lack of interpretability. Results are harder to interpret. And evaluation also, because there is no grounded truth, it is difficult to evaluate the model. Means how you know what is right answer? There is no right answer given. So evaluation is quite challenging. It is also computationally intensive as it involves working with large data sets. Okay, then you have another topic which is basic concepts in machine learning with examples. So again, basic concepts, types of machine learning, supervised machine learning. You have label data. Example is email spam detection. Which algorithm do you use for that? Here we are learning with respect to examples. So example is email spam detection. You can use an algorithm logistic regression. Explanation is given that because the model is trained on a data set where emails are labeled as spam or not spam, so it can classify a new email based on the features into any of the two categories. For unsupervised learning, uh, example is customer segmentation. Algorithm that we are using is k-means clustering. The explanation is that the model groups customers into clusters based on purchasing behavior, identifying segments like bargain shoppers, loyal customers, means grouping the customers based on some categories. Semi-supervised learning example, web content classification algorithm is self-training. The model initially trains a small set of labeled web pages and then iteratively labels more pages using its predictions to improve accuracy. Then reinforcement learning. In this, as we know, there is a reward or a penalty involved. So it interacts with the environment, obtain the feedback, Positive feedback is a reward and negative feedback is a penalty. Game playing is example. Algorithm can be used as cue learning. Explanation is the model learns strategies by playing the game and receiving rewards for winning or penalties for losing. Key components in machine learning. First, you have data. For training data, mm, we use it for training the model. Example include historical weather data to predict future temperatures. Validation data is used to tune model parameters. Example, a subset of historical data is set aside to validate model predictions and adjust parameters. Please remember this part is very important. This part. So let me color this part. This is very important. You must know about it. Test data is used to evaluate the model. Example is recent weather data not seen by the model during training and validation, used to assess prediction accuracy. Feature means it is an individual measurable property or characteristic of data. This is also very important. You must learn individual measurable properties or characteristics of the data. Example for house price prediction, features include number of bedrooms, locations, square footage. Labels are labels. Example is this is the output or the target variable in supervised learning is called as label. Example spam, not spam. Model is a mathematical representation or algorithm that learns from data. Model means it is a mathematical representation or an algorithm that learns from data. Then it is called as a model. Even though it is also a program, but it is different from a normal program as it learns from data. Example, linear regression model that predicts house prices based on features like size and location. Training, the definition is the process of feeding data into the model and adjusting its parameters to minimize the error. That is training. Students, this definition you please learn. It will really give you an edge over others when it comes to machine learning. Example, training a neural network on image data to recognize handwritten digits. Evaluation, these are the methods to assess the performance of a model. For accuracy in classification, mean squared error in regression. The three common algorithms in machine learning are this linear regression, logistic regression, decision trees, support vector machine. Actually, it should not be three. Acha, yeah, this is a third side heading, subtopic. In three, you have all these common machine learning algorithms, decision trees, support vector machine, k nearest neighbor, k means clustering, principal component analysis, neural networks. Those are important and popular machine learning models. Model evaluation and validation, cross validation. Please remember this term. Cross validation means it is a technique to evaluate the model by partitioning the data into multiple training and validation sets. And example is k-fold cross validation. What you do in cross validation is you divide the data into multiple parts. Each iteration chooses a unique part for testing and rest all as training. So alternatively, it chooses different parts as test set. Confusion matrix is it is a table used to evaluate the performance of a classification model. ROC curve means it stands for receiver operating characteristic curve and area under the curve. It measures the performance of a classification model. It measures performance of a classification model. Overfitting versus underfitting. Overfitting means when a model performs well on training data but poorly on new data. It is overfitting. Underfitting is when a model is too simple and perform poorly on both training and new data. Then it is underfitting. Overfitting is when model performs well on training data but poorly on new data. Underfitting is when model is too simple and does not perform well on both training data and new data. Important consideration here is bias variance trade-off. Bias variance trade-off is about balancing the model complexity to minimize the total error. Feature scaling, example normalization. You are scaling features to a range between 0 and 1. This is one feature scaling. One technique is normalizing, where you have all the values between 0 and 1. Another is standardization, scaling features to have a mean of 0 and a standard deviation of 1. Then it is the standardization. Data imbalance means when the number of instances in different classes varies. Uh, if suppose you have a spam and not spam, two classes, and in the data set, when both are not in the same number, spam and not spam, if they are not having same number of instances, then it is called as imbalanced data. The techniques that we use in order to handle this imbalanced data is resampling or smooth. Smooth is synthetic minority oversampling technique. Then ingredients of machine learning. First ingredient is data. As we learnt about data, the foundational ingredient of any machine learning task is data. And the next important ingredient is features. Features, as you know, they are the measurable properties or characteristics of data. Labels are nothing but the outcomes or values that a model is trained to predict. Then next you have model itself. Model is a mathematical representation or algorithm that processes input data to predict labels or uncover patterns. Then you have training. Training is the process of feeding data into the model and adjusting its parameters to minimize errors. Evaluation is assessing the model's performance using specific metrics and validation data. These are all ingredients. Hyperparameters, please try to understand. Hyperparameters are those parameters that are set before training that control the training process and model complexity. So there is a lot of confusion between parameter and hyperparameter among the ML community. Here, this clearly says that the parameters that are set before training to control the training process and model complexity are called as hyperparameters. These are the parameters that set before training. Okay. Feature engineering is the process of using domain knowledge to create new features that improve the performance of machine learning models. Model selection is choosing the appropriate algorithm based on the problem type and data characteristics. Then model tuning is optimizing model performance by adjusting hyperparameters and refining the model structure. Students, these definitions are very important. Please remember these. Cross validation, it is a technique for assessing how the results of a statistical analysis will generalize to an independent dataset. Deployment is implementing the trained model in a production environment to make predictions on new data. Then, what are the problems that can be solved using machine learning models? First problem is classification. Classification is assigning input data into predefined categories or classes, which is classification. Example, classifying emails as spam or not spam. Identifying objects in images like cat, dog, car. Determining the sentiment of a piece of text, positive or negative. Regression is about predicting a continuous output variable based on input features. Then clustering is grouping similar data points together based on feature similarity without predefined labels. That is clustering. Then dimensionality reduction is reducing the number of input variables while preserving important information. Anomaly detection is identifying rare or unusual data points that differ significantly from the majority of the data. Is known as anomaly. Rare or unusual. Then NLP, natural language processing, is understanding and generating human language through text or speech, is NLP. Recommendation system is suggesting relevant items to users based on their preferences and behaviors. Reinforcement learning is uh, here training models to make sequences of decisions by rewarding or penalizing actions. Image and video processing means analyzing and interpreting visual data to extract meaningful information. Time series analysis, analyzing data points collected or recorded at specific time intervals to forecast future values, is time series analysis. Now let us look at output of machine learning with examples. Classification output. The classification output is here predictive labels or classes assigned to input data. So here example, spam, not spam, positive, negative for a disease, cat, dog for image. Regression output is continuous numerical value predicted based on input features. So example is output can be this $350,000 or $150, 10,000 units. So this is all output in numerical form, which is regression. Clustering output is dividing the customer into high spenders or bargain hunters or frequent buyers groups, dividing the customers into groups. Then it can be based on topics. Documents can be clustered based on their topic like sports, politics, technology. Image can be segmented based on the objects, different foreground and background objects. Dimensionality reduction is reducing the set of features or components that capture essential information from the original data. Anomaly detection is identification of unusual or rare data points. Uh, this NLP is processed or generated text data. So it can process the data. Output can be in machine translation. Output is the translated text in the target language. In chatbot, the output is response to user queries. In text summarization, the output is concising the summaries of a long documents. Recommendation output, what is the output for recommendation system? Like this, you might also like this, you might also like that. Reinforcement learning, the output will be the optimal actions or policies to maximize cumulative reward. In game playing, sequence of moves or strategies to win the game. In robotics, control signals or actions for robots to perform tasks. In autonomous vehicles, driving decisions. In image and video processing, processed what does it output? It output the processed visual data with identified or annotated features. Example, for object detection, a bounding box is drawn around the object. For face recognition, the face is identified. For video analysis, uh, a particular video is identified with the activities or the events that is happening in that video. Time series analysis is it predicted the future values based on historical data. Example, output is predicted temperature and weather condition. Here energy demand, output is predicted future energy usage. Economic forecasting, the output is predicted economic indicators like GDP. Okay, next topic is features, the work horses of machine learning with examples. What are numerical features? Features that take on continuous or discrete numerical values are known as numerical features. Example, square footage, number of bedrooms, temperature, humidity, wind speed, daily trading volume, opening price, closing price. These are all numerical features. Categorical features, these are like based on ordinal, means there is a meaningful order, or nominal without meaningful order. Some kind of categories or groups. Features that represents categories or groups are categorical features. Example, in customer segmentation, you can have gender, membership tier, gold, silver, bronze, then marital status, education loan, blood type, smoking status. These are all categories. The binary features are that can have only two possible values, 0 or 1. Example, again, spam detection, spam or not spam. Customer churn prediction means whether customer contacted the customer care for any promotional plan. And then credit card assessment, whether applicant has previous loan or not. Mm. Text features include features derived from textual data like TF-IDF, word embeddings, bag of words. These are text features. They are used in sentiment analysis, document classification, chatbot response. Time series features that are derived from time series data that capture temporal patterns. Example are this day sales forecasting with with respect to daily, weekly, or monthly sale figures, or energy consumption, hourly energy use, temperature readings, day of the week, health monitoring, heart rate readings, activity levels. These are time series. Image features include features that are learned from the image using convolutional neural network like key facial landmarks, pixel intensities, texture patterns, object detection, shape, color, histogram, edges. Medical features include tumor size, shape, texture in MRI scans. Audio features include features extracted from audio data that captures the characteristics like frequency and amplitude. Example is there is a algorithm MEL frequency, septal coefficient, pitch, and then you tempo, beat, spectral features, tone, pitch variation. Derived features means through feature engineering, you can obtain derived features from the existing features. For example, the derived feature include price per square feet, age of the house, distance to nearest school. Customer segmentation derived feature may include average purchase value, feature frequency of purchases. Interaction feature means features created by combining two or more features to capture interaction between them. You can create one feature from two or more features. Example, interaction between age and income, interaction between education level and employment status. Geospatial features, these features capture the geographic or spatial information. Example, latitude, longitude, proximity to amenities, distance, and all. Oh, so this unit 1 was all about theory. Did you understand, students? Any doubts? Yes, did you understand, Shruti? Okay, students, so I'm ending the class now because you have to study. Tomorrow we will continue with the class.